Hello everybody, Steve Matthews here. Today is September 24th of 2019. And you can find me on YouTube under Teeth of the Lamb, all one word, and also on Facebook under Steve Matthews. Today's title is The Moon's Face Can Only Rotate on a Flat Earth, Not on a Spinning Ball. And quite seriously, the fact that we witness the moon's face rotating is an excellent indication that the motions in the circuit of the sun and the moon are exactly as God describes them in Scripture. Over the last couple of days, I've been experimenting with different scenarios on a flat, non-rotating Earth of the moon's circuit, and just by happen chance, I've discovered that the rotation of the face of the moon is quite understandable on a flat Earth. I've put together a little graphic demonstration to help better visualize how the face of the moon can rotate on a flat, stationary Earth. I've placed a green dot on the west coast of the United States, which would be my location, and on the moon, there's another lime green dot that I placed over what would be the Sea of Crises. And of course, the red line would represent the circuit of the moon over the face of the flat, stationary Earth. Watch how the lime green dot passes over the red line, and from the observer on the ground, this would represent actually a true rotation. Even though the moon is in a fixed position on this graphic, which is the Sea of Crises straight up toward the top, it would represent true rotation from the observer on the ground. And also bear in mind that when you visualize this, it actually, if you look at it from above, it's rotating the wrong direction. But remember, from the ground, you're looking at it from the bottom, and it would be rotating in the proper direction. The moon rotates in a clockwise direction, and you'll notice here that those in the southern hemisphere and the northern hemisphere see it moving in the proper direction from their location. So this covers a lot of territory. If you had a slightly elliptical circuit of the moon, and if that circuit were to rotate slightly also, it would account for some of the times when we see the moon not rotating, because as it gets on a straighter area and not so much of a curve, it would appear to stand basically still for 3 or 4 hours, and that's what I observed. Also, an elliptical circuit of the moon would explain why at times we see the moon basically standing still in different areas of the sky. As the ellipse rotates, that would change where it stands still. Also, we see the moon rotate faster and slower in various different areas of the sky, and that's explainable if the elliptical circuit were to rotate as well. Bear in mind, this rotation of the face of the moon is not possible in the heliocentric ball Earth. There's insufficient movement of the Earth to do that. Basically, in the heliocentric model, it's standing still, the moon is. And the Earth is the only motion that you get. And I'll go over that here in a minute. But I wanted to just share this with you and show you that the rotation of the face of the moon does work on a flat Earth, and it doesn't work on a ball Earth. And I'll let others perfect the circuit of the moon over the continents and stuff. I'm not going to worry about that here. The stars and the constellations move in a similar fashion over the surface of the Earth. And in the heliocentric model, they hijack perspective and say that's why you see rotation of the stars and the moon, and that it's not really rotating, it's the Earth that rotates. And we're going to take a look at that. With perspective, as the moon comes closer, it appears to rise in the sky. And as it moves away from you, it appears to set. And that's all perspective does. It doesn't cause any rotation whatsoever. In the heliocentric universe, they would like to have you believe it's all an optical illusion, seeing the stars and the moon go over your horizon in an arched trajectory, that it's all caused by the spin and rotation of the Earth. And that's just utter nonsense, and I'm going to show you why. Here's a globe. It's a professional globe in one of our local stationery stores, and I went down and filmed it. Look how everything moves straight across. There's a slight curvature toward either side of the globe, and it's actually curved in the wrong direction to cause any arched trajectory overhead of stars or the moon. And it doesn't matter which angle you put it at, even a 23.5 degree, it doesn't make any difference. Everything appears to go basically straight across. So you have insufficient arched movement on a globe. So here's another graphical representation of the globe out of the plethora of variations there are. Not even two of them are alike, but one thing is consistent, that the continents move basically straight across. There is no arch to the Earth when it rotates. So how far does the moon move in 24 hours? Well, it moves about 0.5 degrees per hour, and in 24 hours, this is how far it moves. About 12 degrees in our sky, and it's said to be 239,000 miles away. That's a long ways, and 12 degrees becomes insignificant. We aren't getting arch from that. We're not getting it from the spin of the Earth either. So the ball Earth absolutely has no explanation for why we witness the rotation of the face of the moon, other than hijacking perspective and saying, well, that's it. And you're going to see how they jump around trying to convince you of that and resort to fakery and deception, and because it's just not there. If you snapped 3 different images of the moon in the course of one night, they would all look the same. You wouldn't have any rotation on that moon if you took them from the surface of the Earth, because it's just straight overhead. No, what the educators and the astronomers and NASA and all of them would like you to believe is that because you're on a ball, you're moving in a curve and you see everything in a curve. And that's just simply not true. Here's another little graphic to demonstrate what they think is happening, but they'd have to spin the Earth another direction, and you'd have to be on the outer edge of it to get enough curve to see the moon appear to rotate, and it would only be an appearance. No, they would have you think that this is the way you are on a ball. And then as you move across the ball here, you would get an illusion of a spin of the moon. Well, that's just not reality. And they stop at nothing to try to convince you of that. As you saw on a globe, you move basically straight across, and the moon would be straight up and down right in front of your face. So if you took a picture of it, it would not rotate whatsoever. I want to show you a couple of images that I took of the moon. One on the left was in the evening, and the one on the right was in early morning, about 12 hours apart. there's a quarter of a turn on that moon. And that's about what I normally see in our location, is about a quarter of a turn as the moon crosses the sky. This isn't explainable in the heliocentric ball model, and there is no sufficient movement of the Earth or the moon to cause this, and there's no arched trajectory. The only arch is in perspective, and that doesn't cause rotation whatsoever. As you see, my camera is panned from east to west. There's no rotation of that camera at all. It's totally following the horizon. And this is how I took those two pictures. And there's no way to get rotation out of that. Daz, the cameraman, is a well-known troll, and he knows the moon rotates. However, due to the limited rotations and motions available in the heliocentric model, he can't account for the visible rotation of the face of the moon. So he resorts to deceptive photography and clever graphics. And it is absolutely hilarious what he tries to pull. And I'm going to show you that here in just a moment. A link to his video will be in the comments below. And I'm going to show you a couple clips from his video under fair use for critique and commentary. And one thing I want to point out is that he calls this rotation the arched rotation of the moon, and also the constellations and stars. He calls it field rotation, but all that is the rotation of the heavenly luminaries above your head. Just terminology.
So I'm going to run this forward again, and this time we can see more clearly because I'm zoomed up and the daylight is off. We're going to look at the angle of the moon, the apparent angle to the observer. So as I run this forward, we can see that apparent angle is tilting over, and that terminator line is coming up to perpendicular from our point of view. It's rotating clockwise, and now it is tipping over, and I believe that this is what Catfish is talking about, but this is simply caused by field rotation. Let's have a look at this video of this Concorde aircraft flying across the sky from east to west as if we are looking north. This is the sort of view that we would have from the southern hemisphere if we were comparing it to the moon. We can see now that the angle that the aircraft are pointing in our photographs are quite different in each photo. We can see now that the angle that the aircraft are pointing in our photographs are quite different in each photo.
Okay, so he doesn't film what he did. He rotated his body and his camera to get those shots. So let's take a look at some more footage of some airplanes flying overhead, and then we're going to talk about this. Due to the name Daza, the cameraman, I think that Daz prides himself on his vast knowledge of photography, and he is explaining with those jets that fly overhead that's his explanation for field rotation. And I'm going to show you why he is just out of his mind completely. So here we go. Picture number 1 is taken at that angle. Picture number 2 at that angle, and picture number 3. He demonstrated what comes natural to rotate your body as you would have to film something flying over your head. And here are the 3 different angles. So let's look at a little bit more of people actually doing that. A few other clips here. So what do you think just happened there? The guy turned his body and his camera. Whoa, whoa, what's happening here? Hey, that guy's turning his whole body and his camera to get those jets that just flew over his head. So what happens if you quit rotating your body and your camera and just simply lay on your back and film the airplane going overhead? Well, this is what happens. It doesn't rotate. This is a very good example of how perspective works. You can see the jet, as it goes across the horizon, is a ways off the water. And as it gets further away, it goes right into the horizon. And that's the way the sun and the moon both work. Perspective. How does it work? Well, as you get further away, things get smaller and they rise up, or if they're in the air, they go down toward the horizon. And they vanish into the horizon. The vanishing point is what it's called. Perspective, you can have multiple vanishing points. If this would be a good representation, if the moon were to rise and then go down and set on the right, it would vanish into the vanishing point. Kind of like that. The sun and the moon both rise and they set. Just like this. They rise, they move closer to your vantage point, and then as they move back away, they set and vanish in the distance into the horizon. In recap, the moon and the sun and the stars and the constellations all move in a circuit over a flat, non-rotating Earth. And the moon rotates as it moves on its circuit over the flat, non-rotating Earth. So it rotates clockwise, and those in the southern hemisphere see it rotate counterclockwise in an opposite. On a ball Earth, as the Earth spins, you would move in a straight line across the surface of the globe, from east to west, or west to east. There would be no arched movement because you're on a ball. The surface features on a globe move straight across from one side to the other. The Earth doesn't spin in anything but straight across. So if you were to take a picture of the moon, which also doesn't spin, it's said that the Earth is overtaking the moon because the Earth spins faster, and so you wouldn't get anything but one image of the moon. You would never have a rotating moon. So how far does the moon move in 24 hours? Well, it moves 0.5 degrees per hour, and in 24 hours it moves about 12 degrees in our sky. And in 12 hours it only moves about 6 degrees in our sky. And in 9 hours it moves about 4.5 degrees. So during one day the moon has moved virtually nothing in the sky. So please like and subscribe, and everybody have a darn nice day.
What did you just